Thanks, Carter. So I have to admit, this talk is a little selfish because I get way too many support cases about Kerberos, and I hear way too much misinformation about what Kerberos is, does, and how it actually works. So this is as much for my benefit as it is to all of you. Hopefully we'll dispel some nice myths along the way. I have developed quite the presence in the ASF over the past 4 or 5 years now. A few misrendered trademark signs there, but about split 50-50 between NoSQL systems and SQL systems, as well as a handful of my favorite terminology I've been called yet, Sherpa-ing podlings through the ASF project, getting them up to speed. Anytime in this presentation, if you see Apache something, that refers to a project at the Apache Software Foundation, and they have a trademark of that name or registered or not. And today, we're talking about Kerberos, and the room kind of emptied out. But there's kind of a joke about this. I always like to use the term black magic or voodoo. My coworker Steve likes to liken it to Cthulhu and going to the madness beyond the gate. It's all in jest, but there is a little bit of truth behind it in actual, if you ever sit down and have to look at one of these issues. If you get that reputation of the guy who knows something about Kerberos, you're screwed. You're just done. Everyone is going to be coming to you from there forth. So there, I want to at least lay some ground rules of things that we don't want to cover today. This isn't going to be code examples of how you interact with HBase that's running with Kerberos Authentication. This isn't going to be, when you see this error, you need to do this. That's really, I think it's not a long-term positive way to actually address the problem. I think you can go a lot farther. I take myself an example. I learned a lot about how to debug these sorts of issues by actually understanding what the system is trying to do and applying that knowledge to understand what might have went wrong when that happened. So we'll start from the ground up. Kerberos. A network authentication protocol. So we're talking about how do we authenticate a client to a server across 2 nodes. We're dealing with public key crypto technology here, so one of the nice things is that we can run this on any kind of network, right? We don't have to worry about if it's a secured network, if we have access to it. There may be someone else on the network trying to listen to us, and that's okay. MIT Kerberos is what we're going to be referring to when we have Kerberos talked about today. For all you with your OS X laptops, you actually will have another implementation installed, Heimdall. But anytime we're saying Kerberos here on out, it's MIT Kerberos. And going back there, a network authentication protocol. We're not talking about authorization, and we're not talking about any sort of privacy of the data going over the wire. So there's no sort of wire encryption. Anyone can read the bytes going over the wire. So the primary component that you have with Kerberos that you're going to be deployed with your architecture is the KDC. So the KDC's role is to actually grant a ticket to users of the system. So the ticket is the sort of the cryptographically secure bits that allow you to authenticate with another node that you want to talk to. So like anything else, a trusted component, you have to make sure this service is locked down. It's essentially the huge vector of any attack of the security system. You need to make sure you protect it. Users in Kerberos are defined by a principal. There's sort of 2 forms of principals. The middle portion there, the instance, is optional. The primary is sort of the short name, so it typically refers to what you would have, what is your login user on your system. And some realm refers to sort of a domain. So what are, it might be company name, it might be business unit, something along those lines. A typical human would have some short name at a realm. So me, I would be, Elser J at Hortonworks. If I have some service running, you would actually have the instance component. So we would have, HBase is running on this specific host name here. Important first sort of misinformation to dispel. A short name at realm is unique from a short name with an instance at a realm. Those are 2 different things there. So very brief, we're not going to get into the low-level details of how the Kerberos is a secure system, all that. There's plenty of other talks who can do it much better than I can. But essentially, to authenticate, so a user who wants to authenticate with KDC and get a ticket, they have to have some sort of a shared secret there. Typically, for a user, that's going to be a password you type in at the console. For services, you use a thing called a key tab. A key tab is nothing more than some binary representation of some other shared secret. You protect it just like you would a password. You don't want to give it out to your friends. You have it, chmod 600 on the system. You don't want anyone to touch it. When you get a ticket back from the KDC, that ticket is for a certain amount of time, configurable by the KDC, how long you're allowed to have a ticket that's valid for. Optionally, you can have a ticket that actually is renewable. So if you come back before your ticket expires and you tell the KDC, hey, I got this ticket before, I'd like to have it for another 12 hours, 24 hours. You can then renew your ticket without having to go through and get a brand new ticket. And generally they're very simple. Clients, servers, they both talk to the KDC, get their ticket, and they can do authentication between each other. So most of you probably won't have to deal with using KAdmin unless you're setting up like a local KDC or something for yourself. That's sort of your root access to the system. This is where you would create your principals, you modify them, you can configure lifetime on tickets, renewal lifetime, all sorts of fun stuff. The latter two are really going to be the things that you have to use or you have to run before you can actually interact with some system that has Kerberos Authentication set up. Knet is your entry point to actually obtain a ticket. So this is where you would enter in your password on a command line prompt. This is where you would pass in your key tab. And what that's going to do is going to talk to the KDC for you and get that ticket. And it will put it in what's called a ticket cache, which is a special directory in convention in temp at that little suffix name. And that's going to be protected. And then by convention, all these other sorts of programming languages that we'll get to know to look there to pull a ticket automatically for you. KList will have one of two functions. It will either print the contents of your ticket cache, you can see what tickets you actually have, or it can actually list the contents of a key tab to see who you, what secrets are in that key tab and who you could get a ticket for. So just to go forward, if it's not entirely clear why we really like this in, specifically in the Hadoop and the HBase world. Pretty much if anyone comes to you and they say, hey, I want to rebuild this security system, it's probably a really bad idea. There's most likely, unless it's like your specific field of research, you don't want to be rebuilding your security for some distributed system. You're probably not going to do it as well as somebody else can. Like I mentioned earlier with Hadoop, coming out of Yahoo originally, they had very large installations. They had highly multi-tenant systems. There were lots of people on the systems. But how do you know that if you can necessarily trust every single person who's on that system? So even in like on-prem closed off networks, you still have the case of, do you trust all your employees running on that network? Most people are not going to be running on a public network completely. EC2 maybe, cloud network, or I guess I should say GCE too. Anyways, with Kerberos as well, we can reuse the same sort of authentication means across the stack, not just in HBase. We can use it in HDFS. We can use it in Yarn, use it in Hive. We can use it all over the place. And it's great. It feels like a single sign-on sort of thing. And for those who have some sort of Windows authentication domain, they can leverage their Active Directory. They can hook it up through the KDC, and you can get authentication through Kerberos with AD. Great. So, the promise is kind of this, right? You just go, you log in, you go to your terminal, you wrote your first MapReduce job, and you're like, hey, yeah, I'm gonna run MapReduce. It's gonna be great. I'm gonna talk to HBase, and I'm gonna crunch some data. So you get a ticket. You put in your password, puts in a ticket cache, and you run your job, and you're like, yeah, great, I big dated, woo. But the actual problem then, you get these really obtuse errors, and this is where that black magic really comes in, right? I did a KNet, I launched my job, and the error message I got back told me to consider KNet. Yeah, great, thanks. So then you start thinking, okay, what do I Google? Like, I got to search for something here. What do I search for, right? do I search for tokens? Like, what's this UGI thing? Like, what is GSS different from JGSS? Like, is the JCE, what was that? And then eventually you just go get a drink and say, I'll deal with it next week. So, again, before we even get to HBase, let's talk about how do you interact with Kerberos in Java-based applications. Like we were saying, it feels like a SSO sort of thing. So if you have a ticket in your ticket cache, you can launch the HBase shell, you can interact with HDFS, and it's great. You don't have to do anything else. It knows who you are, and you have the guarantee with Kerberos that we definitively know who you are. You know the client knows who the server is, and the server knows who the client is, and it's great. Inside of Hadoop itself, they exposed this special API class called User Group Information, which is one of those first acronyms we touched on, UGI. There's two methods here that are sort of touch on. If you write some code that interacts with some system using Kerberos Authentication in the Hadoop realm, you'll likely see one of these two methods. That's sort of the entry point. So performing a login with a key tab and altering some state inside the JVM for future logins. What UGI really is actually a really thin wrapper meant to try to be a little more useful than the actual authentication methods provided by the JVM itself and the JavaX security subject, as well as the KRB5 login module. So these are the sort of low-level things actually provided by your JDK or the JVM to do that login for you. UGI is just a little bit of syntactic sugar on top. Another sort of related thing, so Jazz is sort of another way that you can interact with that same sort of JavaX security library. You aren't necessarily invoking it directly, but certain client APIs, Zookeeper is one that we'll touch on later, can actually automatically pull from Jazz configuration and perform the login for you based on the configuration that you told it, whether to prompt you for a password, log in with a key tab, etc. So when we're talking about service now, or HBase services, right? Let's bring it back, apply it back to HBase now. When we have these region servers and masters running out in the cluster, we don't have the ability to go and prompt a password every time we start one of these servers. We would never want that, right? We want to be able to automate our services. If a region server crashes, we want to restart it. We don't want to have to wake an operator up at 3 in the morning because a region server crashed, and you have to type in the password to restart it. So that's where key tabs are really great. We have a file on disk, and the service can automatically get a ticket for itself when it needs it, when it starts up. Hunky-dory great. These are configured in HBase site.xml. Each component in HBase has its own pair of principal key tab property. Super. The sort of weird thing that you'll see is that there'll actually be in most, if you get like something from a vendor or someone who actually set it up correctly, you'll see that there's actually Jazz configuration as well in there. So you might wonder, you're like, well, he just told me I put configuration values in HBase site. Why do I need to have this Jazz file as well? Turns out Apache Zookeeper is one of those that actually is, to do proper authentication, it actually needs Jazz configuration set up to do the authentication properly. So HBase actually has a bit of duplicative configuration in there for how you log in. This is necessary inside the servers because there are ACLed components inside of the root Z node that HBase writes to. We need to make sure that HBase is actually authenticated properly as HBase and not just falling back to read-only access. And that last point is one of my favorites of people telling you that they did a KInit with a renewal and they wondered why their region server still crashed afterwards. Total misnomer. Clients are a little bit more tricky, mostly because the actions of a client, what they actually might be doing, are so varied. You might have a short interactive thing like the HBase shell, where you just want to pull from the ticket cache, you're going to run a couple commands, you're going to exit the shell. In other cases, say you have some operation where you have a program that you wrote and you want to run on a daily interval to scrape some metrics, do some analytic, do something like that. You would, in that case, actually want to use a key tab. So there's all sorts of different ways that clients actually can interact with the system, depending on the sort of characteristics of your program, the lifetime, the invocation. It actually will change how you want to do authentication. You can use all these different ways. You can use Jazz directly. You can use the low-level JavaX APIs and do your authentication yourself. It's great. Personally, I would just steer people towards UGI because there are a bunch of different even Java vendor Java implementations, how you use those different components to do login can vary. So like if you're using IBM's JDK, you might actually have to write slightly different code than if you're using Oracle's JDK. Fun. So using user group information out of Hadoop, if you have it available to you on the class path, is really great. And once again, I'll say this about 18 times, your ticket expires. If you're going to be running an application longer than the lifetime of your ticket, you need to make sure you renew it. So touching on those two methods from UGI, we have two that look almost exactly the same. Literally, the method name has a little suffix, and one of them has a non-void return type. So what's the difference? Turns out they're actually extremely different in the implications of what they actually do. The first one there, the login user from key tab, is actually altering some static state inside of UGI, which essentially all other client API implementation in HBase and Hadoop, or HDFS and Yarn more correctly, will be looking at and using. So it's sort of the static, this is the currently logged in user. You can only have one at a time. If you would make another call, it would log out your old user, and you have all sorts of fun times. The second one here is not altering that static state. It's giving you back a UGI instance, and what you can do is you can invoke this method called a doAs. You provide a callable to it, and you perform some computation, you return some value, and that computation is run as the user whose UGI object you have created. So it gives you that ability to have one JVM, but actually act as different users at different times without colliding with one another. So up to this point, we have not actually even talked about how do we do RPCs yet, right? We've just talked with how do I actually log in, and how does this server, how does this all work? So this is where we get to the next acronym, SASL. So the Simple Authentication and Security Layer, RFC 4422 if you actually really want to read up on it. So SASL is what actually lets us build an RPC framework with authentication, but not tied to a single authentication. So the pluggable authentication is the killer thing that really gets us bonus points here. The default mechanism that we're going to be using in HBase for Kerberos is called GSS API, General Security Services API. Great. It can speak Kerberos. We don't have to do anything else. We just say we're using the GSS API mechanism, and it goes to town for us. Awesome. Digest MD5 is another one we'll talk about later when we get to delegation tokens. Another bonus of SASL is that it can actually do some layer of data protection on the wire for us as well. By default, you're just getting authentication, but you can turn on auth_int for integrity checking, so making sure that the contents of a message were not changed over the wire, as well as you can go one step further and do auth_conf, which refers to confidentiality, so making sure that no one else could see the data in transit over the wire. So again, this is what SASL is providing us, but again, Kerberos is not providing us these things. It's just the authentication mechanism. So going back to this trust on an untrusted network thing, this is one of these recurring themes here. And we'll sort of go into why this is important when you actually have a distributed system and you don't necessarily know who you're talking to. You know you want to talk to a certain node, but how do you know that the node you're talking to is the one you want it to be? From Kerberos parlance, it doesn't really care. If you're talking to another service that has a valid ticket, great. You're happy. You can do the handshake, you can set it up, great. But in the case of HBase here, how do we know if the region server that we wanted to talk to is actually the one we talked to and not one that's just masquerading out there that somehow got a valid ticket? So this is where the instance component of that Kerberos principle for services actually is really important. It's not just convention that you always see a fully qualified domain name in there. It actually is part of the security model for doing Kerberos over RPCs. So if we can see this on the right here, right? Normally what you have some client, the client says, hey, I need to talk to this service running on this node. You do a DNS lookup, you get the IPU, you go through the physical address, you get your route, you set it up, and on the remote side it says, hey, I'm this service running on this host, this FQDN, great. You have the Kerberos authentication because you both have tickets. You set up and the SASL side handles okay, you tried to talk to this host, and that host is actually that host, right? So it's relying on DNS to say the host that you thought you were talking to is actually the host you wanted to talk to. Conversely, say if you hit the left side here, somehow you had some nasty guy in between you on this untrusted network who should somehow redirect your packet to a different host. You wanted to talk to service 1, but somehow he got your message and he sent it to service 18 and was going to try to respond to you with that. If he has a valid ticket and you don't have trust over your DNS, how do you know if you actually talk to the right host? So ultimately, DNS here is extremely important when you're actually dealing with a security model. You have to make sure that just as you protect your KDC as like an attack vector, you have to make sure DNS is consistent as well as accurate. You can't let anyone else get in there changing DNS records. You'll have a really bad time. Practically, you'll see a lot more issues with in deployments where people just don't have both forward and reverse DNS rules set up. Causes all sorts of headaches because nobody believes they have a DNS issue. Nobody. You literally have to prove it to every single person that, yes, your DNS is actually wrong. Go talk to your network team. So this is a lot of data. I don't know if I gave that disclaimer, but we're going good here. So client and server, they get tickets. They can talk to each other. Clients typically use passwords. Sometimes use key tabs. Services use key tabs. Woo. Don't forget to renew them. SASL is the framework that we build our RPCs on that allows us to do Kerberos Authentication via GSS API. The quality of protection in SASL is what actually gives us some extra protection over the wire, including wire encryption. Always make sure you have fully qualified domain names everywhere. Make sure your forward and reverse mappings are accurate everywhere. So that's most of it, right? But we do have some edge cases. Now, what happens when you launch a job and you have 1,000 or 10,000 mappers set up, spin up? If we think back to that original thing, okay, when a client needs to talk to a server, they both talk to the KDC. Crap. We just denial of service attacked our own infrastructure with the KDC because we launched 10,000 mappers who all tried to get a ticket from the KDC at once. Not going to work out well. Similarly, take something like the HBase REST server or Thrift servers, one or two, either or. We're using Kerberos here because we wanted a strong guarantee that a client is talking to the server, and we know definitively that each of them are who they say they are. When we introduce this sort of secondary hop, we're talking to the HBase REST server who's talking to HBase for us. Suddenly, we're asking, we expect now to talk for the REST service to talk to HBase on our behalf, right? But this invalidates our entire core model of what we wanted with this strong authentication in the first place. So how do we address these things? So for the MapReduce side, we get these delegation tokens. And if you thought Kerberos documentation was sparse, there is literally one academic paper. I think my boss was a co-author. Thank God he's not here to hear me make fun of him, though. We like SASL because of the pluggable authentication, right? We touched on that digest MD5 mechanism. What this actually is used for inside of here is to implement this delegation token support. I don't know why this is so hard, but a delegation token is nothing more than a temporary password. That's it. It's a temporary password, you protect it, and Yarn gives you the ability to sort of serialize it out and make sure it stays safe as it's transmitted across a network or across a cluster. Make sure other users using Yarn can't access your delegation token. It's the same sort of thing. It's valid for a certain amount of time. You can revoke it if necessary. Great. The awesome part of it is that because we aren't talking to the KDC directly, it's sort of two-edged sword. We can use our Kerberos ticket to get a delegation token. We can store it, but we don't have to, and we can use that delegation token henceforth. We don't have to re-authenticate with the KDC every time now when we're doing stuff like MapReduce. We don't have, each of those tasks don't have to re-authenticate. They can use that pre-shared password already. And again, same sort of thing I said. I won't bother re-saying again. Proxy users is another sort of a little amorphous topic here. Again, it's this problem of we have some intermediate service who we want to perform some sort of RPC, some action to HBase on our behalf. Right? We need to make sure that it's actually happening as the end user, otherwise your ACLs in the system won't work. You'll try to read a table, you get denied, all sorts of fun stuff like that. So the good thing about Kerberos is that your local ticket is not transmitted to the server you're communicating to do some RPC, right? So when you connect to the HBase REST server, you're not actually sending your ticket there. It can't go and do anything on your behalf. So what we actually have, or the way that the Hadoop community at large solved this was this notion of a whitelist. So saying when we have a certain principal who's properly authenticated with their own ticket, we're going to actually allow them to act as a different user. And it's just your very trivial configuration-based, the HBase REST server can act as me, it can act as anybody else, from this certain host, maybe not some other host. Very trivial, not too much going into it, but it helps us do that problem where we aren't talking directly to HBase, and therefore that intermediate service doesn't have our ticket to talk on our behalf. So one final thing we'll talk about, SpinAGo. When we're actually dealing with HTTP components, so things that aren't using like Hadoop RPC style RPC services, we are actually not using SASL in this case. We're using something called SpinAGo, which is an extension to the HTTP protocol. There's a special header in there called negotiate, N-E-G-O, negotiate. Built-in, you can do it on curl, you can do it on pretty much any decent, like higher level web or HTTP client will have the ability to do it for you. It's great. The only real thing to mention here is that if you are doing things in your web browser, so like talking to Kerberos authenticated web UI, so if you want to look at the master or the read server web UIs, you actually have to add some extra configuration to your web browser for that to work in most cases. So finally, the sort of two little things we'll do on when you actually do need to troubleshoot. Make sure that you are using a decently recent version of the JVM as well as Hadoop. Both of these do have bugs. Use a recent version, you should be fine. The Java 8 sort of flip had some as well. Make sure that you do have the Java crypto extensions installed on all the nodes. By default, I think you'll get AES 256 keys inside of the KDC. So your key tab or your ticket will have those strong encryption things. By default, those are export controlled, so you don't get them when you download your JVM from your vendor or product provider, however. Make sure that you actually have debug for at least Org Apache Hadoop HBase IPC turned on in your service logs if you actually want something decent on the server side to tell you why did my RPC fail. There are some client-side stuff. You can also turn these on the remote as well that give you some great debugging from the JVM itself about what was happening at the login layer. DNS, make sure it's actually right. Like really actually verify it. Make sure that you actually think through a problem that you're seeing. Is it authentication or is it authorization? If it's an authorization issue, it's not actually a Kerberos issue. You made your RPC. Ticket expire and actually read the logs. You'd be astounded how many issues just get escalated way more than they should because people don't read logs. Steve Lauren wrote a great book, again, in the style of H.P. Lovecraft about Hadoop and Kerberos. It's a glorious read just because. Your Oracle JDK or JVM docs are a great resource if you're actually programming. MIT Kerberos, if you actually want to know more about how the KDC authentication or Kerberos authentication scheme actually works, this is a great blog post covering the topic. And the KDAG is another tool that's sort of helping to proactively find issues with deployments before you actually run into them yourself in Apache Hadoop 2.8 and greater, or there's also a standalone there in GitHub. And one final plea, actually write tests. If you're going to be deploying code to a system that's running with Kerberos, you have no excuse to not write tests that run against a Kerberized HBase. There's mini cluster support. For HDFS, Yarn, HBase, all of them have the ability to be wired up with Kerberos, and Apache Directory has an awesome little Kirby project, which is great for embedded Kerberos work. And whew, that's it.